Hello everyone, welcome to the Load and View Data tutorial using SIFT. This video will teach you how to upload your motion capture dataset for further analysis using the application. As a prerequisite for this tutorial, we will need a CMZ file. If you have already completed the Visual 3D tutorials, then you should be familiar with this file type and possibly have even gone through the process of building them. If you'd like to build a CMZ for this tutorial, you may use the feature or refer to the tutorial named Build CMZ Files for SIFT, which is available on the HasMotion wiki page. Alternatively, you may opt to download a pre-built CMZ file containing a dataset from the Visual 3D workshop at a recent ASP meeting. This highlights the gait cycles consisting of overground and treadmill trials. The link for this download is also available on the HasMotion wiki page on the pre-existing Load and View Data tutorial. To start the tutorial, we have an empty project in SIFT. The first process is to load in the folder containing the participant data. If you're using the V3D workshop file, then we must direct the application to source the data from it. We can do this by selecting the Load Library button on the left side menu. We must give a library path for the program to source the data from. We can do this by selecting the Browse button and then selecting the folder which includes the workspaces for the participants. In this case, it is a V3D workshop file. I can direct the program to this file, click Select Folder, and then click Load. Now that the dataset has been loaded in, we are able to see the list of workspaces within the main box. We can click the plus button beside them to expand the workspace and reveal the trials it contains. We can verify which file tags are present in the library, and for this example, we have Overground, Run, and Treadmill. This allows us to identify the environment of each trial or other important information about the participant. If you have loaded in multi-subject data, you can verify which subject prefixes and subject tags are present in the library. Just as in Visual 3D, we are able to animate the data contained in any loaded C3D file to examine the trial. We can select the subject through the Workspace File dropdown here, and select their trial through the C3D file dropdown here. Then we can click the play button and verify that the data as the animation is run. As we can see here, we have a subject moving through an overground trial. Next, we can move on to defining our queries/groups. These are the fundamental units of analysis in SIFT. We can navigate to the Explore page with the left side menu, and then we can select the Query Builder button. This opens a dialog box where you may opt to manually create group definitions based on the analysis you are conducting. If you are making your own definitions, you can click the plus button to prompt you to name a query. You would then create conditions for the query by defining how you want to specify signals from the data tree. If you wish to time normalize the signals to a set of events, and if you wish to further refine these signals, queries can have multiple conditions. For example, if we want to group the left and right matching signals, we would have to create a condition for each. More information on how to create a query and considerations for this can be found on the HasMotion wiki page. For now, we can hit cancel and delete. For this tutorial, we will be exploring the auto-populate queries function by clicking on a button on the top left corner of the dialog box for SIFT to automatically generate queries for us. We can go ahead and click this button now. This opens a dialog box that has a tab of signals, combined sides, and refinements which can be edited to your choosing. Since I will be using the default settings, I can now click Create. As can be seen, this generated queries for the angle, moment, and power for different joints of the subject's body, with each query having a condition for the left and right matching signals. I am satisfied with these queries, so I can select the Calculate All Queries button on the bottom of the dialog box. If you would like to save these query definitions, you must select the Save Query Definitions button on the top right of the dialog box. For now, we can close it. We can now visually examine the signals created and begin to really explore the data. We can select a particular group and then check the Select All Workspaces option to display all of the workspaces associated with the selected group. To select more than one group, we can hold down Control and left click on the groups that we are interested in, like this. We can edit any of the settings within the plot editor box and check the appropriate boxes to plot all sequences, workspace means and dispersions, and group means and dispersions. Once changes are made, the plot should reflect these changes automatically, like so. If it does not, you can navigate to the General Options button on the upper toolbar. Make sure Refresh Plot on Selection Change is selected. Otherwise, you will have to select the Refresh Plot button each time that a change is made. We are also able to interact with the data on the graph. We can highlight a trace by left-clicking on it. As you can see, this causes the trace to become more visually prominent than the others. It also produces a tooltip that includes the group name, workspace name, name of the specified C3D file for that trace, the frame range, subgroup name, and the X and Y values of the position I have clicked. We may want to exclude the traces which we believe could be a source of error, or does not truly reflect what is happening during the data collection. Once the trace is already highlighted like it is now, we can simply right-click, select Exclude, and exclude trace, raw data. We can confirm that the trace has been excluded in the Workspaces widget, as excluded traces will have an X beside them like so. Finally, we can save the application project to preserve the work on the analysis done so far. We can do this by navigating to the Save Project As button on the upper toolbar. If you have yet to save a project, then the Save Project button will be available beside it. We can hit on the Save Project As button, name it tutorial1_SIFT, and it will save as an i3D file type. We can click Save As. Now we are able to refer back to the project whenever needed.